Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, editor-in-chief at Automation World, and the question we'll be answering in this episode is AI-powered machine vision really beneficial to manufacturing? So joining me to answer this question is Kevin McCabe with IDS Imaging Development Systems, a supplier of machine vision system technology and related software. So thanks for joining me today, Kevin.
Hey, thanks for having me, David. Glad to be on.
Yeah. So, let's start with the obvious question. Why use artificial intelligence in vision systems at all? And by that, I mean, what benefits does it bring to machine vision specifically?
It brings just hype, right? No. So
There's some of that going around with AI now. Yeah.
Oh yeah, for sure. Man, what a crazy storm we've been in, like past couple
Yes.
months.
Absolutely.
But honestly, the technology in specifically machine vision has been around a while. It sort of started with like neural networks way back, I think in like the 80s. Now we're using them quite often. But the bottom line is, why do you want to use it? It kind of gives you another approach to solving qualitative problems, which can sometimes be difficult for kind of the more traditional rules-based image processing approach to solve. So what I mean by qualitative is, let's take a really, really simple example. Let's say we have like a mixed fruit production line. We've got apples and oranges for some reason on the same line. And we have the problem, okay, we have to sort these. So you can start with traditional rules approach. Okay, we have an expert in machine vision go, how can I differentiate these? Okay, maybe there's some difference in color. Maybe the circularity is different between an apple and orange. An apple's got a stem. You can kind of continue on and on to kind of create these rules, and then you sort of end up having exceptions along the way, and this process takes quite a long time to come to a final solution. And that final solution, could be tested in the field and then end up not actually working. So instead, with the most common AI type of network called a convolutional neural network. With that type of network, you instead feed a big data set to it, basically. And big can be relative. It can be 50 images, can be 100, can be 1,000. And you feed, pictures of apples and pictures of oranges to this network. And you tell it which picture is an apple and which picture is an orange. And then that network, during the training process, figures out what you mean by an apple and an orange. So that's like one of the big things. You can get this kind of initial prototype out pretty quickly, learn from the field, and it's an alternative approach to some rules-based stuff.
Can you dig a little deeper, kind of give us more information about specifically how AI enables vision system use in quality control and assurance in manufacturing processes?
Yeah. So you can take one of these networks and insert it to help a quality assurance or quality control process that a human can do alongside it. So it's, again, networks like this or AI like this is good for qualitative things. Is there screws missing on this part? I only see 3 out of 5. Okay, that's a bad part. Oh, this part's a little askew. There's object detection, which stuff is like, again, counting those screws. There's classification. In the case of like mixed use lines, it can say, this is this part. Let's switch the system to what that part needs versus all of the other parts you have running along the system. And then there's also segmentation, which is it's still useful in quality assurance, but it's sort of one of the steps into using maybe some other techniques. And then finally, there's a really powerful one called anomaly detection those types of networks, instead of having like this giant data set of like good and bad images that you have to provide like a quality control process, which is tough, right? Most modern manufacturing has a pretty good yield rate. So you end up not having, even if you decide to capture data of like all your parts, you end up having way more examples of what a good part is versus what a bad part is. And those bad parts can vary quite a bit in what they are. Like maybe it could be like a scratch on a metal piece, or the metal piece is cracked. Those are already two different types of anomalies that would need examples in kind of more of a classification network. But with anomaly detection, you give it good images, you tell it over and over again, hey, this is the right part. Oh, it's in this different orientation this time. It's still right. And it will learn what is anomalous, right? Exactly in the name, anomaly detection. So it'll trigger, oh, hey, this looks something off. Kick it to another part of the process and have someone look at it. So it can assist humans in getting a better idea of what's going wrong with their products and catching those products before they get to customers.
It's been really amazing to see over the past, I guess it's several years now, how these systems, how easy they have become to train them, where it used to be hundreds or thousands of images that you had to show these systems. Now it can be just a handful of them. I can remember, learning about these years ago, thinking, is it worth it? The amount of time to train some of these systems.
Yeah.
But now it's relatively easy in comparison.
It's kind of gone both ways too, right? They've become easier to train, but also there's just more data out there now. There are cameras and processes that we didn't think needed vision before.
Yeah, as soon as you learn one thing, it's like, oh wait, we could do this, and you can do that. Yeah, it just keeps adding on. So, speaking of that, before we get further into this, I did want to take just a quick second to clarify, what kind of AI we're talking about here with machine visions, just because with all the headlines right now about the large language models like ChatGPT, I just want to make sure the audience understands the difference between that kind of AI and what we're talking about here with vision systems.
So they're actually kind of related. So a large language model is also a neural network, similar to a convolutional neural network. So it has a lot of parameters and it's trained on a whole bunch of data. The most recent ones are just like, here's a bunch of data. I'm not telling you what it is. So it's like totally self-supervised learning, they'd call it, where, again, the user isn't giving you a description of what they're giving you. It's just, hey, here's a bunch of text, figure it out. Where convolutional neural networks are similar is, again, lots of parameters. It can be trained on a huge quantity of data. So where they differ is, again, at least how convolutional neural networks are applied in vision, is you have these large language learning models that are almost more poised at solving any problem that you give them. How well they do that, is getting better, but is up to our judgment still. And in the case of machine vision, we're really talking more of back to a narrow AI approach. So you have this convolutional neural network that, if you know a little bit about neural networks, there's input nodes and then there's the final output. In convolutional neural networks, those first input nodes are actually like filters already. So filters that were used in rules-based machine vision, like edge detection, circularity. The CNNs that we're talking about in vision are kind of almost pre-trained. Like those input nodes are all sorts of rules-based filters already. So you don't have to reteach a network like what's an edge, what's a circle, things like that. And then the network kind of chooses what rules-based techniques almost to use on the image once you've trained it. So it's a very narrow approach to a problem rather than this big, broad generality.
All right, thanks for explaining that. I think that really helps not just myself, but the audience as well, really understand with so much coming out about AI now, to really differentiate between the different types and understand what the similarities are. So, speaking of that, I know that IDS offers IDS NXT, which is an AI powered vision system that it's designed to be easy to use even for manufacturers who haven't used AI vision systems before. Can you explain a bit about IDS and XT and how it uses AI and why you say it's easy to use even for those with no experience working with AI?
Yeah, so the NXT, it's already done like the heavy lifting. So you don't need to learn how to create a convolutional neural network on your own. You don't have to have a giant rack of GPUs ready to train that network. You don't even have to have coding experience. So it's really trying to. This is a little bit of a buzz. It's trying to democratize AI a little bit, right? It's saying there are a lot of different user groups that could potentially touch a system like this. Let's make it as usable as possible for the vision experts, the programming experts, the people on the line, the engineers somewhere in between that have their knowledge of setting up the rest of the system in terms of automation, but don't have a lot of experience in vision. Offloading that task of, or really changing that task of programming a bunch of rules-based rules, or the rules-based approach of machine vision to a network that will help you decide what is best to use and then spit out a result for you really changes the paradigm quite a bit. Again, it changes it from a programming problem over to just a data and labeling problem, and the knowledge shifts to how do you not introduce biases and things like that into the network. But the bottom line is with NXT, you're not starting from scratch. You're using a full ecosystem. The NXT is an embedded vision platform. So it's a camera running a full operating system. It's just got like a ARM/FPGA processor on board. So it's running the neural networks on the camera itself. So that's the hardware part done for you. The training part and programming part is done by Lighthouse, which is a web-based platform where you upload images to a cloud server. All of your data stays your own. Don't worry, we're not stealing anything.
Yeah.
And because it offloads the need for a big giant mainframe to train the networks. We customized a visual coding platform called Google Blockly that basically just allows you to do any logic that you need in a really easy visual format. So you have the basic loop of the camera. Hey, it's capturing every time. Okay, set these parameters up before we start to capture. Exposure time, gain, normal camera stuff like that. Maybe set up some GUI in your Vision app or whatever. That's like the kind of web-based front end of whatever you want to do with the network. Mm-hmm. And then once an image is captured, run this neural network to figure out whether it's an apple or an orange. And then, switch to this next neural network that I've trained to tell me whether this apple is good or bad.
So, with that explanation of basically how the system works and how it's been set up to be easy to use, can you give us an example or two of customers of yours in the manufacturing industries who are using IDS and the types of results they've been able to achieve with it?
So one that comes to mind is actually a 2D pick and place application. So robot arm has to, find a part and find its orientation, and then find a pick point to move it to the next bin. A customer of ours, based on the NXT hardware, trained a neural network in order to do that. So it was able to, I guess you could consider it like an object detection network, but additionally, they added on their own the ability to also tell the orientation of the part. And so with the orientation and the kind of center known location, they were able to find a pick point and move the part onto the next part. At least they demonstrated it with screwdrivers. So not ultra precise kind of thing, but something that had a pretty obvious like orientation in one direction, but it also could tell the rotation of it in the other directions too, from like the flathead front, because the rest of it is kind of similar. So it paid attention to like where the label was on the handle, as well as, like I said, the flathead screw, what orientation the flathead head was on.
How long did it take them to do that training? Because like you said, it wasn't a super precise application, but it was fairly detailed. How long did that take to train the system?
So they initially started out just using the object detection network, and as far as I can recall, that took like a day to set up.
Oh, okay.
And then they wanted to kind of take the technology a little bit further than what we were ready to do with it. So they were also AI experts on the other end. So they handed it off to another team that was an AI expert and went, okay, now we need to know the orientation. So they created their own network that then they uploaded to the camera, and it worked. That part I'm not sure how long it took, because obviously it takes longer to create your own network on its own. But that first part, that first initial prototyping was, within a day.
Now that we've established, a bit of a baseline about AI use and vision systems and how you're approaching the application of the technology industry, can you explain, how adaptable AI vision systems are in terms of accommodating new processes or changes in a manufacturing line? And I'm asking this because I keep hearing more and more about how this is a major issue for manufacturers of all kinds today is, they adapt to changing customer demands, reacting to supply chain issues, and also just with the rise in high mix, low volume manufacturing overall for a lot of manufacturers, especially contract manufacturers.
Yeah, they're pretty flexible. Like I said before, it kind of changes that rules-based problem from a programming problem into a data-driven problem. So if you get a new part, you take some images of it in different orientations or things like that. So if you've got the data, you can take that same vision system that you have already installed in a line that's, let's say, pre-trained for one particular part. You can retrain another network, and then maybe have a classification network beforehand, again, telling the process which part is coming, and then doing the quality control process on it. So pretty easy once you have the camera in. Again, it's still data driven, so it's going to take some time to get those images, as well as have a human label them and then train the network. But still quite a bit faster than rules based, I believe.
And you kind of referenced this earlier, talking about the data going into a cloud-based system and being secure. But just with this idea of AI, consuming and generating so much operational data, are there any specific data privacy and security implications associated with using AI-powered industrial cameras? And if so, how is that being addressed?
Yeah, so anytime you start collecting images on your products, it's going to be a risk, right? I defer to IT specialists to have the real network security type of stuff there. But what we can talk about is how changing the methods of computation can increase the security. So you have a spectrum of choices. You have the expensive self-training within a facility. So you've got this data set, there's a little risk there already, right? But let's say it's on a closed network, no problem. You're just carrying a bunch of images, no big deal. You're keeping it in your company totally. You're doing self-training with a big GPU rack that you've already got, or a big server rack. So not much risk there. And then you have the whole other end of the spectrum that's, okay, I have this completely cloud-based AI decision-making platform that I send an image to, and then it tells me what it is. So every single time a decision is being made, there's risk there going to that centralized server. You can sort of make the choice of having something in between, and I think that's where having an edge-based system can potentially be a little more secure. So you move that computing from the big cloud-based stuff onto the camera itself. The image doesn't even have to leave the camera itself. You can just send the decision out from the camera. So it gets rid of some of the risk there. And obviously there's the elephant in the room for, well, we have an edge-based platform, but we have a cloud-based training. Yeah, again, there's going to be some risk, right? Anytime you upload anything to the internet, someone could potentially grab it, but you can make like some mitigating steps towards that. So something simple is like, I hate to hate on the US here, but like go to a European server. They have to comply with GDPR like really hard. Yeah. So even having something like that, it won't stop malicious actors as much as just companies grabbing your data. But again, another mitigating factor. Another kind of tangentially related thing is with all this data capturing, even within your company, I've worked with 2 or 3 companies now, I think, that really focused on like, they were capturing pretty broad images of like a process. And sometimes one of their workers could be in there, and they wanted to make sure that data was anonymized. So like they would still be sending the image off of the embedded platform onto somewhere else for like storage, just to gather more for their data set, but they wanted to remove the person from it. Hey, an AI network can do that for you. If you can run a person detector network on the camera, and then it goes, okay, blur this section out, there's a person here. You're already improving privacy there.
So it sounds like from the way you describe it, it's a lot of the same cybersecurity protection methods that are used for all industrial systems. I mean, there's the IT focused operations in-house. There's verifying the cloud security, based on what type of public or private cloud you're using. I guess the difference is that anonymizing feature that you might have to use depending on what sort of pictures. That's kind of the difference, but the processes are largely the same.
Yeah.
So one last question for you, Kevin. How can businesses start integrating AI vision? What are the first steps they should take?
So it's gather data, right? So we've talked about the shift of AI from programming-based problem to data-driven problem. You got to have the data in order to solve it with AI, for sure. So plunk a camera on your process somewhere. That's like step 101, right? After you've gotten the data, you can start out with something like we recently brought some of our AI networks actually just to our 2D cameras. So the AI stuff we have is no longer exclusive to NXT. So you can take a 2D camera, use it with our regular free API, and start training a network. So that's definitely a good path forward. You have just a 2D camera. You have your computer doing the work. It's going to be slow, right? But it's a start. It'll give you an understanding of what the possibilities are for it to solve. And obviously, reach out to companies like us. We've done a lot of work with a lot of people, and we can't obviously say all of the specifics, but we have an idea of what kinds of problems can be solved with this technology.
I suspect there's a lot of companies who are looking at this, who are getting ready to take the leap and figure out how they can start using it. And I guess, like you said, the first step is to take that first step and just start with something simple and go from there.
Computing power has come a long way. That's the big reason why we're even talking about convolutional neural networks right now. It was a brute force problem in that they couldn't solve in the 80s. I think the 80s with their current computing power, and oh man, has it changed?
Yeah,
in 50
and it's
years.
changing. Yeah, and it seems to be what we're seeing now with AI applications. Just it's changing month after month. Well, thank you again for joining me for this podcast, Kevin. And thanks, of course, to all our listeners. And please keep watching this space for more installments of Automation World. Get your questions answered. And remember, you can find us online at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.